Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
So let's talk about the different types of plate boundaries. Remember we talked there is convergent, divergent, and transform. And they can either go together or apart, and we have ocean and continent. So it's like, oh, there's a lot of options, Mr. Bergmann. That's right. So what we want to do is, let's say that we have ocean, blue, and ocean. All right? So the first one, this is actually the one that kind of leads to all of them, is we can talk about the divergent boundary. So what you can see happening right here in this image is it's coming apart. You see this? As it comes apart, what's happening is it's producing like a volcano underwater, right? And we call this a mid-ocean ridge. It's spreading across. If you look right here at Google Earth, what you'll see is that it going right down the Atlantic Ocean, there's this ridge. An interesting thing that happens is the youngest rocks, right? This is when it comes from magma into rocks, it forms. The youngest rocks are in the middle of the ocean. So an ocean-ocean divergent plate boundary, what's going to happen? You are going to create, pretty cool, you're going to create a mid-ocean ridge. What about if we take an ocean-ocean and we have them collide with each other? This is pretty cool. Now watch what happens here, right? As these two ocean plates are coming together, do you see what's happening? Now one of them is more dense than the other, and you see what's happening, even though they're both ocean and they're both made of this roughly the same density, one will be a little bit more dense than the other. Do you see how it's diving underneath? And as it dive underneath, there's a big fancy word. All right, write this down, people, people, people. When one plate dives under another, we call that subduction. Subduction is it dives underneath, it gets super hot. And do you see what's happening? Is it's all these bubbles, that's like hot magma lava, like gazillions of it, and it makes this feature we find on the Earth. We call it a volcanic island arc. All right, let's where do we find this? Again, Google Earth. You see where this is happening? Right here at the Aleutian Islands off the coast of Alaska. And you can see that, also one other note, you can see there's also an island arc, but you also have a deep trench. So really deep parts of the ocean are right there. You'll see a trench and island arc, and this is crazy, crazy cool to see this right here too. What are our other options? Yeah, that's right, ocean continent. Now we've got, so we're gonna have let's do the, when they come together, so this is a convergent, they're coming together. Now, notice what happens. The ocean is more dense than the continent, and as it comes in, do you see how it's subducting underneath the other? And do you see the bubbles? The bubbles! The bubbles is molten lava, and what do you see is you see a chain of volcanoes on the land. Now, where do we find this? We just have to go to the western United States, right across the coast, Mount Shasta, Mount St. Helens, Mount Rainier, and we have this exact same thing happen. And there's an island, a set of, not an island, there's a set of volcanoes across there. That's why you see lots of volcanoes in this particular area. You might think in this next one we could have a divergence between ocean and continent, and it turns out that just doesn't happen very often on the Earth, so we will skip this one. But you can do this, where we have a continental, when they diverge. Now again, watch what's happening. As it splits, sometimes actually you could get what we call a rift valley. We see this in Africa, at the Great Rift Valley of Africa. And if it's a big enough split, it will actually form a sea, an ocean, and it's how we create new oceans. Now, a couple more. We haven't talked about the transform boundary. So in the transform boundary, I won't do the animation on this, but what happens is we have ones where they go side by side. This is called a transform boundary. You have these slipping and sliding, the plates going back and forth, and we'll learn more about this, but this is what causes lots of earthquakes. You get earthquakes here too, by the way, but you can get significant earthquakes here. The San Andreas Fault is a classic example of this. And then lastly, I want to talk about something that's really a kind of a cool phenomenon, kind of really helps support the theory of plate tectonics, and that is the idea of what we call hotspots. So it turns out that, when you're on the Earth, okay, is that and then you've got the crust, right? There might be some parts, it's hard to see maybe from your perspective, but this little part, let's say here, is just a little bit thinner. And that means that the gap between, the hot stuff's down here, and there's some spots on the Earth that we call hot spots because the crust is thinner there, and because it's thinner there, it's easier for it to escape. Think of the lava escaping. Woo! And what's going to happen here, and this happens usually, by the way, in oceans, so it's happening in oceans, is it's going to form an island. But of course, what's also going on, if you think about it for a moment, just a volcanic island. The classic example of this is, maybe you've been there, Hawaii is this example of a hotspot. So you've got a hotspot, the Hawaiian island, but you might know that there's not the Hawaiian island, but the Hawaiian islands. And what's happening is that the crust is moving. So as it moves, or the plate on the top is moving, so this plate is moving, and then what's happening over time, but the hotspot's still in the same spot, and so what happens is that this island is, after a time, over here. And then what's going to happen here is, so this island's gone. It's going to then form a new island here. And what you get is you get a chain of islands. It's actually the islands on the crust that are moving. It's not the source of heat, if you will, is coming from the exact same place in the center of the Earth. But since the plates are moving, you can see this. Let's take a look at Google Earth. Take a look right here. And what you can see is you can see this chain of islands. You can see some islands that are now have been eroded away that are underneath because what's happened is the plate has been moving. So fascinating thing, isn't it, to learn about how we make things. We've been talking about how to destroy them, erosion and weathering them, but this is how we make them. We have to do one more. I just realized I forgot one, very important one. What if I've got a continent, right? Continent, and they converge. This is how we make the biggest mountains in the world. Watch. They come together. A continent collides with a continent. And what you get is you get something like these mountains, the Himalayan mountains. Crazy, amazing. So this is a convergent, continental, and you get something pretty amazing. Plate tectonics. You might think it's hard, Houston, but it's not. Houston, we don't have a problem.